Hi students, my name is Sakesh from Irrigation College 9. Today we are going to study one more important topic, that is. Hi students, today I am going to teach water harvesting, and conservation. This is coming under in module 5. What do you mean by water harvesting and conservation? My name is Sakesh. I'm from AJ Engineering College, Mangalore. What do you mean by water harvesting and conservation? Water harvesting means it is a rainwater. Is one of the, we can say, the water, how we can store and how we can utilize for future any need time. How that is called water harvesting. It is we can say store water and use for needy time, or we can say that one where when the need arises, and conservation also. That is one more technique to use water and store and use water in that future using. The most efficient availability of what it's water harvesting in that in the rainwater harvesting we are using for when it is rain comes, we are storing that water and further when the need arises, in that time we are supplying the water for future water for public use. That is called the water harvesting system. So this principle of water harvesting and conservation is this is the many techniques used for water harvesting systems. We can say we can harvest the water using rooftop techniques. Rooftop techniques means water will collect from the rooftop, and we can make it small trench and use that water for further use. That is also one of the techniques. And first we'll discuss about what is the principle of water harvesting techniques. Principle of water harvesting and conservation. Principle of water harvesting and conservation. Principle of water harvesting and conservation. First it designing the which techniques to use to make more efficient use of available water. It is important to consider how crops receive or lose water. Crops receive water through rainfall and or irrigation and stored soil water. They lose it through runoff, evaporation and drainage, or some key principle effective of water management are. So for example, this is the one crop. When we are water using for this for crops, so the water will use this is the root. Water use this plant by different techniques. What we are pouring the water right now. When rainfall comes, water, this water it will use, and rainfall water it will use. And here the two we can divide it two times. One is loose water and another one is receive. Crops receive or lose water. How we can receive? This is rainfall is receiving water. Lose it, and another one is receive. Crop receive water. Lose or receive water. How we can lose it? How we can lose the water this crop? By lose the water by using evaporation, but receive rainfall, receive by rainfall systems. When its rainfall comes, water will use, this crop will use. And another one is irrigation and drip irrigation, different irrigation systems, irrigation system that supply the. And next, stored soil water, these different techniques they used in deciding which techniques to use to make more efficient use of available water. One is it is important to consider how crops receive or these crops receive or lose water. This is receive means rainfall, the water will receive. And also same time irrigation and stored soil water, also the water will this plant will utilize that water. They lose through runoff. This it means this water will lose because of runoff. And evaporation, runoff also one of the reason. And evaporation and drainage. And what we can use conserve this is the lose and receive the water. I said that this is the runoff. Also the water, when it's soil is fully filled with water, there is no infiltration, so water is converting it as runoff, so that is also lose of the water. And evaporation, water will be converting to liquid state to gaseous state, that is called evaporation. And another one is drainage also, when the water, if it paved surface, the water will directly converting into runoff, the water will go for this one. So that is all the loose water. And receive water, I said the rainfall, irrigation and stored soil, everything is received water. So how we can manage the effective water management? So what is the key principle effective water management are, that we need to discuss here. So what is the key principle of effective water management? Key principle of effective water management. Key principles on effective water management. Key principles on effective water management. What is the key principle of effective water management? First one is, what is the key principles of effective water management are? First one, use rainwater effectively. Use rainwater effectively. And how we can say it, in many climates rainfall is distributed unevenly in intense downpours that cannot be readily used by crop. Storage techniques such as external catchment or rooftop collection increase the availability of water in drier season. They also harvest water from wider area, making more water available to the crop. Measures can also be taken to avoid the rainwater. How we can use rainwater effectively? When rainwater comes, so for example, this is the one house. So what we can do, the rainwater will fall here and the paved surface here, and it will not store anywhere. It will not store anywhere. It will go directly to the sea or any. It will reach to the sea directly. If you are not stored that one, it will going to be waste. So we can't use further our use. So that reason, use rainwater effectively. How we can use rainwater effectively? So this is the diagram I am showing here. So all the rainwater we should store here. You can make it one small trench and you can store the water. It will recharge the groundwater and we can use in drier season. You can use in drier season. You can make it trench make trench and use it for further use. So use the rainwater effectively. And next point is make effective use of soil water reserves. Make effective use of soil water reserves. That is also important. Second point, make effective use of soil water reserves. How we can say that one? The soil stores water from rainfall. We all know that soil stores water from rainfall, providing a reserve that is available to the crop. How much water is available depends on the soil type and the rooting system of the crop. So here soil, we know that when water, this is the soil. So when water comes, so this soil becomes moisture, and this soil stores water, right? No, so soil stores water from rainfall, providing reserve that available to this water the crop will use this soil water, right? No, this water soil will use. So we can divide this one, soil type and rooting system of the crop. That how we can use this, because the how much water is available depends on the soil type and rooting system of the crop. It depends on soil type and how much water available of water depends on soil type and rooting system of the crop. Soil types here, example, sandy soil, holds less water. We can say sandy soil holds less water. Sandy soils holds less water, and clay or hold good quantity of water. Clay and soil, clay and or silt soil holds good quantity of water. Good quantity of water. So here soil type sandy, if it is soil soils holds less water, and if it is clay or silt soils, good quality of water it will stores. And rooting system also, I said that rooting system also, it depends. It's two types of rooting systems. One is deeper rooting. Two systems of the rooting system is this. One we can say deeper rooting and shallow rooting. Deeper rooting. Another one is shallow rooting. Deeper rooting, example, grasses. Shallow rooting, example, vegetable crops. Using this one, we can say how much availability of water. Deeper rooting we can grasses, and shallow rooting we can say that is vegetables. So using this material, we can say how much water its resource, soil water resource, and take measures to avoid runoff. Next one is key principles of effective water management to measure. Take measures to avoid runoff. Take measures to avoid runoff. Take measures to avoid runoff. Water is not absorbed by the soil but runs across the surface. So how we can control that? So because runoff means when it's soil moistures, when soil, this is a soil moisture, when rainfall comes, the soil is filled total. When this soil moisture is totally filled with water, the rainfall is not infiltrating soil, it will converting it as runoff. It is converting it as runoff. So water is not absorbed by the soil but runs across the surface. This is called runoff. So how we can store this water? To make the structures, different structures called terracing, pits, bunds can reduce the. We can make it contour bunds, contour schemes. We can make contour schemes. And next one is terracing. And next one is, we can say, pits, and next one is bunds. So using these techniques, using all these techniques, we can reduce the runoff to avoid the runoff. And next one, avoid wasting water through evaporation. That is also one of avoiding wasting water through evaporation. How we can reduce the evaporation? So avoid wasting water through evaporation. Avoiding wasting water through evaporation. How we can avoid this? Water that evaporates directly from bare soil and it's wasteful and is not being used for productive plant growth. So water directly from bare soil is wasteful, it's not being used for productive water. It deserves to maintain a full groundwater cover as much as of time is practically possible. Applying much to the soil will also reduce evaporation considerably. Use of drip irrigation technique. If it is bare soil or dry soil, the water evaporates fully. So how we can control? Use drip irrigation technique. So in the drip irrigation technique, we are not using much water. Bare soil, water evaporates fully, and drip irrigation techniques control the maximum quantity of water loss because of evaporation. This is also one of the best key principles of water management. And next one is reduce water losses through drainage. Reduce water loss through So next system is reduce water losses through drainage. So how we can make, when water drains out of the soil, nitrogen is washed out. Adding compost manures retain the water in the soil. When water drains out the soil, nitrogen content is washed out. Nitrogen also washed out. So we can see reduce water losses through drainage. When water drains out, when water drains out the soil, nitrogen also washed out. Nitrogen content is also important. Nitrogen content also washed out. So how we can retain to that contents? To adding composite manure, composite manures retain the water in the soil. So next one is plain irrigation. That is also one of the important terms. Plain irrigation, that is, irrigation is one way of supplementing water from rainfall and its soil resources. Irrigate water when it's necessary. So that is also one techniques to retain the water in that soil surface. So irrigation is one way of supplementing water from rainfall and soil resources, but can waste large amounts of water if not used carefully. A key way of making the most of the water supply is to only irrigate when necessary. Many people irrigate on a regular basis whether the crop needs or not. If water is scarce, irrigation should be restricted to the most critical periods, such as germination as fruit set. Drip irrigation makes much better use for water than overhead system and is targeted to the roots rather than spray deep into the air. So we can say that plain irrigation is the technique. Irrigation is one way of supplementing water from rainfall and soil reserves. Water from rainfall and soil reserves. So but it can waste large amounts of water, because when we need that water, that time they are not supplying the water. When the root needs, or that crop needs that only we should supply water. Unnecessary supplying water, huge loss of unnecessary supply of water, huge loss of water takes place. So which one is drip irrigation techniques? Technique is proper water usage techniques. Drip irrigation techniques is a proper water usage techniques. So next, which one is water harvesting techniques? Next we'll discuss about water harvesting techniques. Next is water harvesting techniques. What is the water harvesting techniques? So we are telling that is micro catchments. We know that catchment means what? So catchment means when this total watershed, this is a higher elevation, when water touches, when rainfall comes here, all the water is contributing into this river, and it's finally it's reaching to the sea, and this is the outlet. So here it's all the water is connecting to the sea. So we can say, so this total catchment, we are dividing, this one is small catchment, here also small streams is connecting to this one. So this small catchment is, we can convert it, calling it as micro catchment. This one is calling as micro catchment, this one is calling as micro catchment. So this is the catchments and this is the micro catchment. Higher, so total bigger catchments we are converting at small catchment, that is converted as micro catchment. Okay, so how we can increase the water harvesting techniques using in the micro catchments, that is important. A micro catchment is specially contoured area and with the slopes and berms designed to increase the runoff from rain and concentrate it in planting basin where it infiltrates and effectively stored to the soil profile. So a micro catchment is specially contoured area. We can say that one, specially contoured area, specially contoured area. This is a contoured area. This is specially contoured area, and it's increase the runoff. Increase the runoff in this. Here the techniques they are using and contoured with slopes and berms designed to, how we can increase designing slopes and berms. Slopes and berms, it will protect the side of bund. So where it is infiltrated and effectively stored in the soil profile. The water is available to plants but protected from the operation. Stored in the, this one stored in the soil profile. Stored in the soil profile. This one is stored in the soil profile, and it will this water they will use in when the water is available to plants but protected from the operation. These benefits of the techniques are improved soil moisture, runoff and groundwater recharge, and soil nutrients, increase the biomass production and subsequent higher yields. Everything this is increase the, this techniques is increase the soil moisture, design slopes and berms, and increase the moisture content of the soil. It is increase the moisture content of the soil. This increase the moisture content of the soil. The main advantages of this one is, what is the main advantages of the in simple, and it's inexpensive, and low salt content and inexpensive. This is simple techniques. We can say this is a simple advantages. Simple techniques and inexpensive, and the runoff water has low salt content, and because it does not have to be transported or pumped, it is relatively inexpensive. The runoff water has low salt content, and micro catchment enhance leaching. It is enhance leaching, reduce soil salinity, reduce soil salinity. So, and this is the important terms for that techniques wherein we can use for water harvesting techniques. And what is another one is how we can what is the one is micro catchment, another one is farm pond. What that one we'll discuss in. What do you mean by farm pond? I'll say that. Next one is micro catchments, and then is farm pond. This is one small type of ponds. We can see the diagram in your notes, so please refer your notes for more detailed diagram. So farm pond is a large hole dug out in the earth, usually square or rectangular shape on a small pond. This kind of small ponds they are constructing. Here this is the outlet, and this one is silt pit. We can say this is a silt pit, and this one is inlet, so water will store here. So this is square or rectangular in shape, and erosion is prevent banks of bunds. So these banks of bunds prevent the erosions, and the size depends on amount of land available, and this is size is depend on, you can write it here, this square or shape is square or rectangular shape is square or rectangular, and next size depends on amount of land. Size we can develop bigger size also. Amount of land available, the size, and site selection. How we can select the site for this farm pond, and we can write it here, site selection. Site selection for farm pond. One is overland drainage. Second one is groundwater. Impounding flowing water. Impounding flowing water. And next one is other sources. This is the different selection. Drainage area of annual precipitation rates will be determines if water supply is adequate. So that is when comes in overland drainage. So if in that site selection, overland drainage will comes, the surface runoff from precipitation, melting snow or spring flowing overland. Drainage area and annual precipitation rates will determine if the water supply will be adequate. So this is overland drainage. This is surface runoff from precipitation. This is overland drainage will depend on surface runoff of the precipitation and melting snow or anything, any kind of different rainfall. We can divide it. And precipitation means anything we can consider. Flowing overland flow is there, no? That one drainage area of annual precipitation rates will determine if the water supply will be adequate. So using that one we can consider for constructing the farm pond whether it is water available, if the water whether it is sufficient or not, we should check it, because we are considering only the runoff rainfall. Rainfall means runoff from the precipitation, how it is runoff is comes generating, that what is the quantity of generating the runoff, everything we can check it here before constructing site selection. And groundwater. Ponds which acquire water mostly from groundwater are often called water table ponds. They are built by excavating below the water table at the location. The level of the water will be equal to that water table at any given time. In some cases, what happens, underground springs may be present. Springs of flow underground pressure, because this should be in the level of groundwater. You should be dig in a very deeper condition, so then only we can compensate in that water. Sometimes the spring also developing in that, so it will be more recharge. If it is springs developing, the more water will generate, and it will be useful for improving the groundwater recharge and also for our future use. So that is also one important key points for that groundwater. And another one is impounding flowing water. This can be plentiful water source for a pond. Impounding flow, that is we can say this is can be plentiful water source of pond. However, impounding flowing water can have adverse effects. It can block fish passage, warm the water downstream, add excess nutrients to your pond, and cause sediment from upstream to fill your pond. The latter will require occasional removal. Heavy flows can also be difficult to contain. So Generally, more problems are encountered with this type of pond and are not recommended to be built in this way. So it will be sometimes it will disturb for the ecosystem. So that would meant some, maybe that is not suggestible for some reasons. And other sources, if water available for other sources, because we can say that roof water, diversion from the excess water from the drainage, that water we can use for this pond. So this is the site selection for the and construction farm fund. How we can construct this farm fund? After the site selection and pond dimension decided, the pond dimensions, the site should be cleared of all stones and wood vegetation should be removed. That we can say that one how we can construct the construction fund. There is a general form. General equipment used for pond construction are pulley wheeled scrappers and draglings and bulldozers. The use of bulldozer for excavation usually limited to relatively small ponds due to inefficiency in transporting the material. So we can that depend on criteria, how the people available labors and what is the size of the ponds. Everything it's depend on that site conditions and size of the farm pond. So related to that we can say what kind of material we can use for construction of farm pond. So that different machines also we can use for related to that one. Pulley wheel scrappers, draglings and bulldozers, everything we can use for depend on that conditions and site conditions and economy of that project. Everything it's we should consider that one. And depth and side slopes of farm ponds, that is also important. The depth of the pond is generally determined by soil depth, kind of material excavated and type of equipment used. The selected pond depth should have a depth equal to or greater than the minimum required for the specific location as a depth of pond is most important dimensions among the three dimension. In semi-arid regions, the evaporation losses can be reduced by deepening the pond depth for the same volume of water stored as lesser in the area occupied by the pond. So this is also depend on that pond size and the area of total area of the population of that area. So how much water we can recharge. So everything we can consider for when you're considering these designs and side slopes and depth. We can consider related to that demand of that area. So this one we can say if you are constructing huge, that side slopes also related to that also we need to make design. So that is also important parameter for that one. And dimensions of farm ponds, this is also important. So everything I have given in notes, please refer that notes. Dimensions and the diagram is also there. So advantages of farm ponds. What is the advantages of farm ponds? They provides water to start growing crops without waiting for rain to fall. So if you are having the store water, so there is no need to maintain the rainfall. So it will be create some backups of water. So that is one of the big advantages for creating the farm ponds. And next one is they provide irrigation water during dry spells between rainfalls. So when dry periods, we can get the water from these ponds. So we can use for irrigation purpose. That is also important advantage of the farm ponds. And bunds can be used to raise vegetables and fruit trees and thus supplying the farm household with an additional source of income and of nutritious food. So they promote fishing. The recharge of is also useful for, that is one of the important. Whenever you are water storing, the one main advantage is it will recharge the groundwater, and this improve the drainage, and this promote the fishing, and the escorted earth has a very high value and can be used to enrich soil in the fields, leveling and constructing the farmlands. And one more thing is a percolation tanks. That is also one more important terms is the percolation tanks. How we are using percolation? Reduce the surface runoff and storage water. Why we are using the percolation tanks? Next we will go for percolation tank. What is a percolation tank important? It is reduce the surface runoff and storage of water. It will reduce the surface runoff. It will reduce the surface runoff and storage of water. Surface runoff, and it will surface runoff, it will reduce surface runoff, because it's more runoff means it will going full it's going to the sea. So that reasons their percolation tank can be used for reduce the runoff and percolate and recharge the groundwater storage. So that is important, and this storage and it reduces runoff and which is useful to storage of water, and it is used for it is reduced surface and used for storage of water and increase the groundwater recharge. Increase the groundwater recharge. So recharge of the main important is this is the one is artificial recharge techniques. Artificial recharge techniques, because natural recharge means automatically water is infiltrating into the soil and the groundwater increase the groundwater table. That is called natural recharge. This is the artificial recharge technique, and is constructed for third order streams. It is constructed for third order stream. Third order streams means, so this is the catchment. If I am explaining related to the catchment, so when the water diverting, this is one. When it starts the streams, it means tributary of the streams. The first stream is called first order stream, and this is second order stream. When it reaches here it will convert. It's two is connecting here. This is the third order streams. So here if we are constructing, we can say this is the percolation tanks we are constructing in third order streams. Benefit from is the main benefit for benefit from the augmented of groundwater. So this is your main usage of what we can say, the percolation tanks. This the more details we can get it from notes. This is small description I have given why we are using the percolation tanks. So next one is rainwater harvesting. Rainwater harvesting. It's a very easy topic. Rainwater harvesting, why we are using. So rainwater harvesting means when, as I told before, so when water is, this is the one small residential house, when water is falls down here, when soil moisture is totally saturating, so soil moisture is totally saturating, so what happens, the water is converting as runoff. So this water will going to be waste, so and it will reaches to the sea. So what we are doing here,